All right, welcome everyone to our Python data and scripting workshop. This is the first of 4 sessions where we will be learning about the Python programming language and the Jupyter Notebook. My name is Dr. Jessica Nash, or you can call me Dr. Nash. I have a PhD in material science and engineering from NC State University, and I work as a scientific software developer at a place called the Molecular Sciences Software Institute. So I'll be one of your instructors for this workshop, and I'm joined by my co-instructor, Dr. McDonald. And so Dr. McDonald, could you introduce yourself?
Hi, everyone. My name is Dr. Ashley McDonald. I am a chemistry faculty member at Cal Poly San Luis Obispo, which is one of the 23 California state universities. And I work with Dr. Nash a lot on teaching these types of workshops to different groups of students. And we're really excited for this workshop and all the things that you're going to learn.
Yes. Okay, and so what we're going to be doing in this workshop is we're going to be giving an introduction to the Python programming language. But the examples that we're going to be using are going to be sort of related to molecular science or chemistry. If you're not a chemist, don't worry too much about that. It's just maybe the data that we're going to be using underneath is going to be chemistry related, but the skills that you're going to be learning are applicable to a wide range of different fields. So I do have some slides to start us out to kind of explain, give an intro to this workshop, what you're going to be learning. So this is our Python data and scripting workshop. This is held by the Molecular Sciences Software Institute, which this big figure on our slide here is our logo. And we are holding this using the nanoHUB platform. So I have a few goals with this presentation. I want to tell you about the Molecular Sciences Software Institute, and this will be of interest to you if you're studying chemistry or molecular science. I also want to tell you just generally about the Python programming language and sort of its connection to data science and molecular science. So the first thing I want to cover is, what is the Molecular Sciences Software Institute? We were launched about 5 years ago, and we're funded by the National Science Foundation. We're a collaborative effort between many different universities. And what we do at the Molecular Sciences Software Institute is we serve and enhance software development and programming skills in the computational molecular sciences, which is a broad field, including quantum chemistry, computational materials science, and biomolecular simulation. The branch of MolSSI that's relevant to sort of what you'll be doing in this workshop is something called MolSSI Education. So MolSSI Education, since 2017, we've had over 1,200 students participate in workshops like the one you're participating in today. And our curriculum, this is sort of what I use to describe our curriculum. It's languages and tools used by software developers and data scientists in the context of computational molecular science. So we're going to be learning the Python programming language during this workshop. We also teach specific Python libraries that are relevant to data science and machine learning, like pandas, or things relevant to software development, which we won't really be going over in this workshop. So MolSSI Education engages, what we do is we attempt to engage a global and diverse audience. We have a number of partnerships and collaborations that we do that with. And so if you're interested in MolSSI Education, our website is education.molssi.org. We do have a number of tutorials there for you to access if you're interested sort of after this workshop ends. So I know many of us, in being that we are the Molecular Sciences Software Institute, I have to say a little bit about molecular science. And I know many people in this workshop are perhaps chemists or physicists or biologists. So what is molecular science? Molecular science is the study of the behavior of matter on the level of atoms and molecules. And that's important because we know that all matter is made up of atoms and molecules. So if you are a molecular scientist, you might look at something like the water droplet on the left, and you might think of an H2O molecule, which is shown here with the red and the white. after you think of the H2O molecule, you might think of maybe several H2O molecules interacting together. And actually, this next picture here is supposed to be a movie of molecules moving, but it looks like my movie didn't quite make it. But this movie, if it were working, is from something called a molecular dynamics simulation, which is a computational technique that is used to study atoms, or used to study molecules. So just computational molecular science means using computers to study molecules. If you are in a physical chemistry class, physical chemistry is very important for this. But the thing that sort of molecular science has in common with data science in this aspect is that when we do things like this, we generate a lot of data, and we have to have a way to analyze that data and to kind of draw conclusions from it. So, oh, there goes my movie. It was just on the next one. So some applications of computational molecular science that you might be interested in. It has a lot of different applications. It's used in medicine. So for example, it's been used to study the virus responsible for COVID-19. So that's a pretty hot area of research right now. Computational molecular science can be used to model battery materials. And then I've also highlighted a recent example from Google. So this is something from Google called AlphaFold that can be used to predict the structure of proteins. So I said on the previous slide, one thing about computational molecular science is that when we do computational molecular science, we have a lot of data that we generate, and we need a way to analyze that. So that's sort of where I think the connection to data science comes in. So data science is the extraction of insights from large amounts of data. And this is relevant in in scientific fields. It's relevant in like business. There are lots and lots of places data science is used these days. In order to be a data scientist, there are a lot of different skills that you need. And this figure is something called the data science Venn diagram. And so that highlights different skills that you need in order to be a data scientist. And so a lot of these do happen to overlap, I think, with science. So you need math and statistics knowledge, you need expertise in a particular field, but importantly, here on the left in this red circle, you need something called hacking skills. And so that refers to programming. And most of the time, it actually refers to programming using the Python programming language. So hacking skills, we can think of that as our skills in using Python and the Jupyter Notebook. Okay, so now that we've gone over that, let's say exactly what Python is. So Python is a programming language. It's been around since 1991, so it's about 30 years old. It's open source, which means that it's free to use. And it is very widely used in data science, for example. So it's the #3 most loved programming language. And consistently, if you look up programming languages for data science, you'll see that Python is listed as sort of the #1 best programming language for data scientists. And it just keeps getting more and more popular sort of as the years go on. So we know that Python is used for data science, but in general, it's actually a very multi-purpose programming language. So Python is used in a lot of different areas. It's used for websites. And one example of that is actually that you may be familiar with is Instagram. So Instagram uses Python. It's used in data science and machine learning. And these bullet points are Python libraries, which we'll learn about what that means during this workshop. But it's used in data science and machine learning. So these are different libraries that are used for data science and machine learning. And so, for example, examples of places that use data science for machine learning would be things like Spotify or Netflix. And then it's also used in a number of scientific and numeric applications. There are a number of other areas highlighted here as well. And during this workshop, we're going to be focusing on sort of these bottom 2 areas. So we're going to be looking at using Python for applications relevant to data science and machine learning, and then also scientific and numeric applications. So that's sort of where we're going with this. Okay, so that brings us to the Jupyter Notebook. That was Python. This is the Jupyter Notebook, and this is something that you'll become very familiar with during this workshop. The Jupyter Notebook is a Python environment for writing code and presenting information. And I've shown a screenshot here of the Jupyter Notebook on the side. And so we are going to be having lots of practice with the Jupyter Notebook starting today. Okay, that was my very brief introduction to sort of what Python is and where we're heading in this workshop. And now I think I will turn it over to Dr. McDonald, and she'll take us through the nanoHUB platform and talk a little bit more about sort of the programming aspects. We'll get started with that.
All right, welcome everyone. I am going to share my web browser open to the nanoHUB web page, okay? So hopefully everyone can see I'm at nanohub.org. And if you look in the upper right-hand corner, you can see that I have logged into my nanoHUB account. So the first thing you should do if you're just getting started is you should go to nanohub.org and you should sign into your account. And then once you're signed into your account, you should be basically on the same page that I am on. Then I'm going to come up here to where it tells me I'm logged in and you can see my name. And then I'm going to go to my dashboard. Here's my dashboard, and yours may not look exactly like this, which is fine. But over here on the left-hand side, I'm going to go to my groups. Okay, and then I'm, of course, a member of the MolSSI group, as I think all of you are as well. And I'm going to click on the MolSSI group, and it's going to take me to the MolSSI page. And then if I scroll down a little bit, we can see the link for this training, the Python data and scripting training. So I'm going to click on that. And then once I'm here on the information about the training, this may be the page that you joined the Zoom meeting from. Right here above the Zoom meeting links, you see this link in red that says, we will use the Jupyter Notebook on nanoHUB for these exercises. And I'm going to click here and it's going to launch the Jupyter Notebook for me. And in fact, I'm even going to open it in a new tab. All right. So this is what it should look like if you click that Launch Jupyter Notebook link. And you can open it in a new tab or not, it doesn't matter. And then if you see this button here that says Launch Tool, that's what you're going to click on. So I'm going to go back through those steps again. After you log in, go to your dashboard, go down to your groups, click on the MolSSI group, come down and find this workshop, and then click on this link that says Jupyter Notebook on nanoHUB, and you should see a window that looks like this. Once you're on this page, I want you to click this button that says Launch Tool, and it'll spin around for a moment, and then it will launch your notebook. And it will look something like this. You may not have these same files here, and that is okay. I'm going to go through the steps again to launching the Jupyter Notebook. You're going to go to nanohub.org, your main nanoHUB page. Then if you go to the upper right-hand corner here where I'm logged in, you're going to go to your dashboard. Then you're going to go to your groups. You're going to click on the MolSSI group, scroll down and click on our workshop. And then you're going to click on this button that says using the Jupyter Notebook on nanoHUB. And then you're going to click this Launch Tool button. And when you do that, you should see a page that looks like this. And you've got to be at this page to proceed any further. So it's totally fine if you don't have the same folders that I have. That's not a big deal. We're going to actually import some files that we're going to use during this workshop as our next thing. So it's totally okay if you don't have any folders here. That's fine. Okay, So the next thing we're going to do is we're going to import the data that we're going to be working with in this workshop. And there's lots of ways that you can import data into your nanoHUB. You can just use this little button that says upload, and then you can upload something from your computer. However, if you use the upload button, you have to upload every single file individually. And Dr. Nash and I want to give you a bunch of stuff all at one time. So Dr. Nash has prepared a folder for us on a file hosting site called GitHub. And we're all going to pull the data from the folder that Dr. Nash has put together for us on GitHub. And this seems complicated, but it's really not. So if you come up here to where it says new, you're going to go to the application called Terminal. And it's going to open in a new tab. And then this is all you have to type. There's a lot more you can do with Terminal, but we're not focusing on that. We're focusing on just this one thing. And you should type in get clone and then put the new link that Dr. Nash posted for us, and it will copy everything over, and then it will tell you it is done. And when it does that, you're going to click back to your home page, and you're now going to see that you have this new folder called MolSSI Workshop. And if you click on that MolSSI Workshop, I'm going to do that again. If you click on that MolSSI Workshop, you're now going to see a folder called Data. And I don't want you to click on this folder called Data. I want you to stay in the MolSSI Workshop folder, but make sure that you can see the Data folder beneath you. Okay? So again, from your home, click on MolSSI Workshop, and then you should see the Data folder, but you should not click on it because I want you to do the next step in the MolSSI Workshop folder. Okay? So once you're to this step, I want you to come over here to the upper right-hand corner, and I want you to see where it says new. I want you to click on that, and I want you to make a new Python 3 notebook. And that will open a new tab, and it will look something like this. And you'll see the nanoHUB logo in the corner, and you'll see the Jupyter Notebook logo in the corner. All right, so I'm gonna go one more time through what we're gonna do. So after you type in the command, get clone, and then the link that Dr. Nash provided, it'll run through a couple things, and then it will say done. Once it says done, click back over to your home page, and it should look like this. Then click on the folder that says MolSSI Workshop, and then you won't click on this data folder, but you should be able to see the data folder. And then from the MolSSI Workshop folder, I want you to come over here to where it says new and go to new Python 3. And that's going to bring up a window that looks like this. While we're waiting, I'm going to put Dr. Simeon on the spot, and she can decline if she wants to. But Dr. Simeon, I know that a lot of these students are your students. Did you want to say anything else motivational about why they should want to learn Python?
Oh, I believe Dr. Nash covered it earlier. Even though a lot of times we've used nanoHUB for physical chemistry labs and also the class, but it will be very instrumental, when a lot of students apply for internships this summer, to have these skills, Python and Bash scripting. And also, this Python can be used in a number of different other fields, such as biology, computer science. So just understanding the basics will be, I think, very beneficial for their career here at Dillard and then after they leave Dillard. So hopefully they'll take advantage of this live training. And thank you again for doing this.
No worries. All right, so we're now ready to get started. So once
Dr.
you're
McDonald?
all... Yes.
I'm sorry to interrupt. Would you mind showing one more time, clicking on the MolSSI Workshop folder and starting the notebook?
Sure. So after you finish this step where it says done, click back over on your other tab that was your home page, and you should now see a folder called MolSSI Workshop. I want you to click on that MolSSI Workshop folder. You should see a folder called Data, but you should not click on Data. You should be in the MolSSI Workshop folder when you come up here to New and click on Python 3. And what that's going to do is it's going to open your new notebook that looks like this. Okay, now anytime you open a new notebook, the first thing that I always like to do is change the name of the notebook. Because right now, the name of the notebook is Untitled, which isn't going to be useful to me later on when I try to remember what this notebook is about. So the first thing I'm going to do is I'm going to click on where it says Untitled, and I'm going to give the notebook a new name. And since this is the introduction lesson of my workshop, I'm going to call it Introduction. And then I'm going to click Rename. All right, then in my first cell, I always like to write a message about what I'm going to be doing in this notebook. And one of the really great things about the Jupyter Notebook is that it lets you incorporate multiple elements. You can incorporate equations, you can incorporate text, and you can incorporate code. So if I want to include some text, I'm going to come right here where it says code, and I'm going to use the little drop-down menu, and I'm going to change this to a markdown cell. And markdown just means I want to put in some plain text. And if I put in one big hashtag and then I put a space, then that's going to format this as like a title for my notebook. So I'm going to make my title MolSSI Workshop. And then on my next line, if I put two hashtags, then I can put like a subheading underneath MolSSI Workshop. So I'm going to call this Introduction. And then I could type anything else that I wanted. I'm just going to put the date for today, but you could type literally anything that you want. Now, when you're ready to run the cell, when you're ready to actually do the things that you've typed in, you're going to hold down Shift and you're going to push Enter. And since this is just a text cell, all it's going to do is neatly format your text. But in a minute, when we start writing our code cells, that's how we're going to run our code. Again, the things that I've done here is the title of my notebook was initially Untitled, and I clicked on that, and it gave me a way to rename it. So then I just typed in a new name for my notebook, and I chose Introduction because this is my introduction. Then in my top cell, I went right here to this little drop-down menu, and I chose a markdown cell. And in a markdown cell, this is just a text cell, okay? So if you put one hashtag, you can put a big title. If you put two hashtags, you can put kind of a subtitle. But really, you can type anything that you want here. It doesn't have to be what I've written at all. You can type whatever you want. All right, so now I'm ready to begin my code. At a first order, Python can work just like a calculator. If I say 3 plus 7, and then I hit Shift Enter, then it tells me the answer is 10. And that's not really very useful. In order to make this useful, I have to be able to set variable names and give those variables values, okay? So I'm going to start off by creating a variable called delta H, and I'm going to give it a value of negative 541.5. And there's no particular reason I chose that number. And then on my next line, I'm going to create a new variable called delta S, and I'm going to give it a value of 10.4. And on the next line, I'm going to create a value called temperature, and I'm going to give it a value of 298. Okay, now, if you were my students, at this point, you would be like, wait, McDonald, there's a problem here because you don't have any units. And you've always said that a number with no units is not a measurement, it's just a number. So it turns out we can't store our units in the same variable with our number. But if we want to write a note to ourselves to remind ourselves of what the units are, we can just put the hashtag, and then we can write any kind of note that we want. So I'm going to note to myself using the hashtag that delta H is in kilojoules per mole, delta S is in kilojoules per mole Kelvin, and the temperature is in Kelvin. And when you do this, when you write little notes to yourself with the hashtag, that's called a comment. And Dr. Nash has a great saying, comments are always for people. They're never for the computer. So the computer is not going to interpret this in any way. The computer is just going to ignore this. So if you write a comment, it should be something that has meaning to a person, either you or someone who's going to use your code later. Okay, now if anyone has been in physical chemistry, what do you guys think we can calculate from delta H, delta S, and temperature? It's delta G. I can calculate delta G. So I'm going to create a new variable called delta G, and that's going to be equal to delta H minus temperature times delta S. And then if I execute my cell, remember I do that by holding down Shift and pushing Enter, it's going to be a huge letdown because nothing is going to happen. And the reason nothing is going to happen is because I didn't tell it to print anything. I didn't tell it to tell me the answer. So if I want to see what the value of delta G is, I have to say print, and then in parentheses, put what I want it to print. And I want it to print delta G. So there is my answer. Okay. All right, so that's it. We've written our first code. We've calculated delta G from delta H, temperature, and delta S. All right.
One important thing to note here is that the capitalization matters. So if you type delta capital H, you have to type it capital H again when you use it. So Python is very bad at guessing what you mean. You have to tell it exactly.
And another thing that I mess up a lot is spelling. So like I spelled temperature correctly here, so I have to be sure that I type the exact same thing in my formula when I want to use it. Okay, but I want to show you one other thing about variables in Python. And if you have programming experience in another language, this may be different than what you learned about other this may be different than what you've learned about other languages, okay? So I've just printed delta G. Everybody has seen me do that. Now I'm going to do this. I'm going to say delta G times 1000, and then I'm going to print delta G again. And if you notice, nothing happened. Like I multiplied delta G by 1000, but then when I printed it, it wasn't multiplied by 1000. It just printed the exact same thing again. And this is a feature of Python. You cannot change the values of variables in place. If I really wanted to change the value of delta G by multiplying it by 1,000, I would have to sort of resave it as delta G again. I would have to say delta G equals delta G times 1,000. And I don't really want to do this, so I'm not going to push enter. But my point is, you cannot change a Python variable in place. If you want to change it, you really have to resave it as the same variable name. And that is different than some other programming languages. So I just wanted to point that out. Okay. Now, I know a couple people are still catching up. So this next piece is sort of, optional. But I want to show you that I can actually assign all of these variables at one time. I can say delta H, comma, delta S, comma, temperature equals, and then I could put all three values. Negative 541.5, 10.4, 298. And then I could do the exact same thing I did before. I could calculate delta G by saying delta G is equal to delta H minus temperature times delta S. And then I could print delta G, and it would tell me the exact same answer that I had before. And my only point is that this code block is functionally identical to this one. It's not doing anything different. And you may be like, well, McDonald, I don't like this. I don't like assigning all three on one line. I'm never going to do that. I'm just going to pretend that you didn't even tell me this. And that's fine. But a lot of people, when they're starting out programming, a lot of people start out by looking at code that other people have written. And if you see something like this, where somebody has assigned three variables on one line, I want you to understand what that means. Okay? Should I pause here?
Yes, I believe so.
And I do see someone who said that they got a name error. A name error 90% of the time is a result of misspelling. It's where you spelled something one way when you defined it, and you spelled it a different way when you used it in a formula. You fix the spelling and now you're not getting any output. That could be fine, because if you don't tell it to print anything, it doesn't give you any output. So you might try putting print delta G and seeing if you get the answer then.
Maybe you could go over the markdown cell again.
Okay, so right up here at the very top, this isn't strictly necessary, but whenever I start a new notebook, I always like to start with a markdown cell. And to get a markdown cell, you come to this little drop-down box and you go to markdown. And in a markdown cell, you can type anything that you want. It's just a text cell. And if you put one hashtag character, that makes like a big title for your notebook. And if you put two hashtags, that gives you kind of a subtitle. And then I chose to write the date here, but I could have written anything. I could have written literally anything, and it would type it out there. And this is just a bonus thing. If you, this is a bonus thing. If you're still trying to catch up with Dr. Nash, then you do not need to do this at all. But see where I'm going to click in my delta H cell, and I'm going to insert a new cell. Okay, so I'm going to go insert cell above. So now I'm going to have a blank cell here. And I can actually show you how to put an equation in this cell. If you go to Markdown and then you put a $sign, you can type an equation and it'll type it out for you. So I can do delta G equals delta H minus T delta S, and then I close it off with another dollar sign. And now, oops, I screwed up a tiny bit somewhere. Oh, I forgot the space between my delta and my S. And now, look, I have like this super nice typeset equation. So you can actually do a lot of things with Markdown that are very neat. That was just a bonus lesson for those of you who are waiting while we're letting everybody catch up. I'll let you see what I typed in my equation cell again, so that those of you who are interested can see how I did my little equation there.
Dr. McDonald, could you summarize the idea of cell 2?
Yeah, so in cell number 2, what I was doing is I was defining 3 different variables. And all you do to define a variable is type the variable's name, an equal sign, and then the value. The name, an equal sign, and then the value. And you can do these on separate lines like I did here, or you could do them all on one line like I did here. Once you have variables defined, you can use them in an equation to calculate a new variable's value. If you want to keep track of something like the units or write any other notes to yourself, you can use these comment characters where it's just the hashtag and then some words. All right, so I'm going to go down and I'm going to be in my new cell here at the bottom. And this is going to be kind of a new topic. So I'm going to change it to a markdown cell. And I'm going to put a little heading about what I'm about to talk about. And I'm about to talk about data types. So I'm going to do 2 hashtags, and then I'm just going to type data types, since that's what I'm about to talk about. And then when I hit Shift Enter, it's going to neatly format that section heading. Now, data types are something that I've discovered are one of the most confusing things for new programmers, partially because they don't understand why they're important, and partially because they're very hard to understand. Okay, so if I say 7, do I mean the number 7, or do I mean the word 7? Because those are actually 2 different things. Okay, the number 7 and the word 7. And you're like, well, McDonald, I don't care which one you meant. I can probably figure it out from the context. And that's true, but the computer can't do that. The computer has to really know whether you mean the word or the number. And that concept, telling the computer what kind of data it is called a data type. And every piece of data in Python has a data type, even if you don't know it. So for example, if I do type, and then in parentheses, I put one of my variable names like delta G, it is going to tell me the type of this variable. Now, delta G was like a decimal number, okay? Delta G was a decimal number. So its data type is float, or floating point number, okay? Now, I can also change the type, I can change the data type of a variable if I want to. Like, let's say that I wanted to make this a word. I could have a new variable called delta G string, and a string is what Python's data type for a word is, or for text. And I could force delta G to be a string by saying str, and then in parentheses, delta G. Now, if I check the type of delta G string, it tells me that it's a string. And more importantly, if I try to do math on delta G, that totally works. I can add 50 to delta G. But if I try to do math on delta G string, it gives me an error. It says you can't do this because delta G string is not a number, even though it looks like a number. If I print delta G string, for all the world, it looks like a number. But if I check the type, it is not a number, so I cannot do a math operation on it. And I know that this is very abstract, like data types are very abstract generally, and it's hard to see why they matter. But in our next lesson, we're going to see why data types really matter. All right. Okay, so let's go on to a new section. And when we go to a new section, I like to make a markdown cell and put a little section heading. And the next thing we're going to talk about is lists. So I'm going to call this lists. Okay, so a list is a data structure in Python that has more than one variable. Or not more than one variable, that has more than one value. So I'm going to start by creating a list called energy kcal. And when you want to have a list variable, you put square brackets, and then you put the elements of the list separated by commas. So instead of just having one number for energy kcal, I have a list of numbers. Okay. Now, there are several operations that I can do with a list. The first thing I can do is I can figure out the length of the list. So I'm going to create a new variable called energy length. And the way that I determine the length of a list is I just type len, and then in parentheses, I give it the name of the list. So this is going to find the length of energy kcal, and it's going to save it as a variable called energy length. And then if I print energy length, it's going to print the length of the list, which is of course just 4, which we all could have predicted. Now, I might forget what this 4 is if I, come back to my code later. So I can actually do I can print in more sophisticated ways. So I can say print, and then in quotes, I can type something. The length of the list is, and then I can put a comma, and I can tell it to type the length, energy length. And then if I hit Shift Enter, you can see it will print my little sentence there. Now, there's kind of a problem with my little sentence here, which is that I'm missing a period at the end of my sentence. Okay. And if I wanted to add a period, it would be kind of tricky because I'd have to come back up here and I'd have to do a comma. And then I can't just say print a period. I've got to put that period in quotes. And then when I Shift Enter, it looks dumb because it puts this space between my number and my period. So there's actually a far better way to print things in Python. So I'm going to say, particularly if you want to print like sentences or like formatted text. So I'm going to say print, and then in my parentheses, I'm going to start with a big capital F, and then I'm going to have opening quotes and closing quotes. Just a single quote is fine. And now I can type anything I want in any formatting here. The length of the list is energy length. Now, when I hit Shift Enter, this is going to not quite be what I want because look what happens. It says the length of the list is energy length. It literally printed the words energy length instead of printing what I actually wanted it to print. So to fix that, if what you want it to print is the value of the variable, not the variable's name, you enclose it in curly braces, and then I can put my period, and now my sentence is all perfect. This technique of printing is called F-string printing because it starts with the F here. And remember, you type print, and then in the parentheses, you put an F, and then you can type anything you want between the quotes. And the names of the variables should be enclosed in curly braces so that it will print the value instead of printing the actual variable name. Okay, now that printing, that was kind of a bonus lesson there. I want to get back to talking about my list. Okay, so when you want to access a particular element of the list, like if I wanted to print this element of the list, I wanted to print the negative 2.7. The way that you access a particular element of the list is you type the list's name, and then in square brackets, you put which element of the list you want. And when you're putting which element of the list you want, this is very, very important, so make sure you're listening. When you're putting what element of the list you want, in Python, counting starts at 0. That's really important, so I'm going to say it again. In Python, counting starts at 0. So minus 13.4 is element 0, minus 2.7 is element 1, 5.4 is element 2, and 42.1 is element 3. So if I type print energy kcal square brackets number 1, this is going to print negative 2.7 because since counting starts at 0, this is element 0, this is element 1, this is element 2, this is element 3. Okay, so to access a particular element of the list, you type the name of the list, and then you put the index of which one you want in square brackets. And the key is remembering that counting starts at 0. Okay? Now, one thing that you want to do a lot with lists is sometimes you will need to take a list and you'll want to make a new list that is a subset of your old list. And that's called taking a slice. When you want to make a new list that is a subset of your old list. So this is the syntax for taking a slice. You put the name of the new list, an equal sign, then you put the name of the old list, and then in square brackets, you put the starting index, a colon, and then the ending index. Now, the way that this works is that the starting index is the first element that you want to include in the new list. And it goes up to, but not including, the number that you put for the ending index. Okay? Now, this isn't a real line of code. This was just something I want to remember. So I'm going to comment that out with the hashtag. And now I'm going to do a real example. I'm going to say, let's create a short list. And I'm going to set that equal to energy kcal bracket 0:2. So what this is going to do is this is going to go to energy kcal. It's going to start with element 0, and it's going to go up to, but not including, element 2. So if I print short list here, it is only going to include element 0, which was negative 13.4, and element 1, which is negative 2.7. Because the way indexing works is it starts with this number and it goes up to, but not including, this last number. Okay? Now, there's two other things that I want to mention about this. If you leave off the first number, it will automatically start at 0. So if I delete that 0 and I just have :2, then it's going to automatically start at 0. So this would actually be exactly equivalent to what I already had. If you leave off the ending index, if you leave off the second number, it's going to go until the end of the list. Okay? So now it's time for a little quiz. Let's do a little quiz. Okay? I'm going to create two variables, slice1 and slice2. Slice1 is going to be equal to energy kcal bracket 1 : slice2 is going to be equal to energy kcal bracket :3. Okay? So what I want you to do, this is your quiz. I want you to think about what you think these two slices are. And then I want you to write print statements and print them and actually check your work. Check and see if what you thought was correct is really correct. Okay? And remember, what you're doing is you are thinking about what you think these two slices are, and then you're going to write print statements to check yourself. Okay? So let's look at this. So slice1, I have 1 : so that means I'm going to start at index 1 and I'm going to go to the end of the list. So I would expect slice1 to be minus 2.7, 5.4, and 42.1. So let me do a print statement for that. I'm going to use my F string printing, but you can do whatever you want. And I'm going to say slice1 is, and then I'm going to have it print the value of slice1. So I'm going to put that in those curly braces. And sure enough, minus 2.7, 5.4, 42.1. Now let's look at slice2. That was :3. So the fact that I don't have a starting index means I'm going to start at 0 and I'm going to go up to, but not including, index 3. So I would expect slice2 to be minus 13.4, minus 2.7, and 5.4. So let me do another print statement and check myself here. Slice2 is, and then I want to have it print slice2 for me. I guess I should have a period at the end of my sentence. And it's just like I said, it's minus 13.4, minus 2.7, and 5.4.
Dr. McDonald, can you go over the :3 in more detail?
Yes. So when I say :3, I do not have a starting index. I did not put in a beginning number. So I know that means I'm going to start with index 0. Then my ending index is 3. And I remember that the way that this works is I go up to, but not including, index 3. So I'm going to start at index 0, and I'm going to do 0, 1, and 2, but I'm not going to include 3 because that's the way the indexing works. It's up to, but not including that ending index. Do you think that's the clarification people were looking for, Dr. Nash?
Yes, thank you.
Maybe. Okay.
Yes, thank you.
All right. So here's something that I could have done earlier, but that I didn't do. Okay. Let's say I wanted to make a new variable called kilojoules, and I wanted to change energy kcal index 1, which remember index 1 is actually this number, negative 2.7. I wanted to change it from kcals to kilojoules. And I remember from PChem that to do that, I multiply by 4.184. And I guess I should have printed it if I cared about it. And I could do that. I could do a calculation using one of the elements of my list. Okay? I could do that. I've already learned how to do all the skills to do that. But really, what would be even better is instead of just doing this calculation for one element in the list, I could actually do it for every element in the list. I want to do a calculation on every element in the list. And the way that you do that is you use something called a for loop. So this is the syntax for a for loop. You type the word for, F-O-R. Then you type a variable name. We're going to talk more about this variable in just a second. And then you type the word in, I-N, and then you type the name of the list, whatever your list name is. Then you're going to have a colon, and on the next line, you're going to indent, and then you're going to do things with your variable that you specified. Okay. Now, this isn't real code. I just want to remember it for later. So I'm going to comment it out with the hashtags. And now I'm going to do a real example. I'm going to say for number in energy kcal colon next line, kilojoules is equal to number times 4.184. And then I want to print kilojoules. Now, before I run this for loop, I want to really talk about what's going on here, okay? So this variable, the word that I've chosen to put here, I've chosen the word number. Number is going to be each element of my list. So first, number is going to be minus 13.4. And then number is going to be minus 2.7. And then it's going to be 5.4. And then it's going to be 42.1. So whatever variable word I put here, and I could put anything I wanted, I just chose number because that made sense to me here. Okay, whatever word I put here, that is the word I'm going to use inside my for loop when I want to use an element of the list. Okay. Another thing I want to emphasize is that indenting is really important, okay? Because there's no equivalent of like an end statement in Python. The only way it knows what you want to be in the for loop and what you want to be outside of the for loop is the indentation. And the Jupyter Notebook is smart. If I put the colon, it'll automatically indent for me on the next line. And if I forget my colon, it won't indent. So if I see it not indenting, I'm like, oh, wait, I forgot my colon. Okay? So let's run this cell and see what happens. It's printed 4 different numbers because it took each element of energy kcal. Each element had a turn being number. And then it took that and converted it to kilojoules using the formula that I gave it. Okay? Now, right now, this code is not as useful as it could be. Because right now, after it prints this, it's gone forever. I'm not saving these numbers anywhere. And you're like, well, McDonald, what I really think you should do is you should make a new list, and then you should put these numbers in this new list so that it will be saved at the end. Okay, so that's what I'm going to do. So the syntax for adding something to a list is this. You type the name of the list, then you type a dot, and you say append, and then in parentheses, you put the new thing that you want to add to the end of the list. Okay, now that's not real code. That's just something I want to remember. So I'm going to put the little hashtag to save it for myself. And now I'm going to try this again. I'm going to say for number in energy kcal, colon, indent, kilojoules equals number times 4.184. But now, instead of just printing, I'm going to do that new thing I just talked about. I'm going to make a new list called energy kilojoules, and I'm going to append that value that I just calculated. Okay? And then down here at the bottom, outside of my for loop, so I'm going to unindent, I'm going to print that new list, energy kilojoules. Now, if you're on top of it and you've already run this code cell, you can actually see that this doesn't work. This gives me an error. And you're like, McDonald, why would it give me an error? That all made sense to me. Well, let's come down here and look at the error message. It says energy kilojoules, and this is a thing Dr. Nash taught me. When you're reading the error messages, scroll all the way down to the bottom, and whatever the end of the error message is probably the most useful piece. Okay? So it tells me that my error is that energy kilojoules is not defined. So what happened here is that I tried to append to this list called energy kilojoule, but that list didn't exist because I had never made it. So what I'm going to do is I'm going to come back here, and outside of my for loop, I'm going to create that energy kilojoules list. And initially, I don't have anything to put on it. So I'm just going to put just empty brackets, okay? So that's going to create the empty list so that when I try to append to it, now this is going to work. And now you can see I have a new list with all of my values in it. All right, so I really feel like we're getting somewhere with this code now. We've got a for loop. We can do a calculation on every element of the list. It seems like this is really working out for us, okay? Now, there's one other thing that I want to show you about lists, and then we're gonna take a little break. I don't know if you normally take a break during class, but we're going to take a break, okay? But I'll have one more thing I want to show you before we take a break. Okay. Another thing that you can do in a list is you can make a choice. You can check something and then do one thing if it's true and do another thing if it's not true. Okay. So I'm going to set up another for loop just like I did before for number in energy kcal. And now I'm going to make a choice. I'm going to say if number is less than 0, colon, and then I tell it what I want it to do if number is less than 0. So I'm going to make a new list called negative energy. And if number is less than 0, I'm going to append it to that list. Okay? Now, if I want to have an alternative, I can also do an else. I can say, if number is less than 0, do this, and if it's not, do this other thing. I don't really have an alternative here. If it's not less than 0, I want it to do nothing. So I don't have to have that. I don't have to have that else alternative. Okay. And then I'm going to print negative energy at the end. And notice that I am unindenting because I don't want to print it until I'm finished with that whole for loop. Now, when I run this, I discover I've made the same mistake I did before. I forgot to define negative energy. So I'm going to come up here outside of my for loop and make my blank list negative energy. And now I can see that sure enough, only the negative numbers have been put on this negative energy list. Okay? So this is a way that you can make a choice in a for loop. You can have an if statement and then a colon. And if this is true, then it does these things. If you want to, you can have an else alternative. But if you want it to just do nothing if it's not true, you don't have to have an else alternative. It is optional. Okay? And I did less than here, but there are a lot of other operations that I could do. I'm going to make a markdown list of those other operations. I'm going to say these are logic operations I can use. And then I'm going to make a list. Equal to is 2 equal signs. Not equal to is an exclamation point and an equal sign. Greater than is greater than. Less than, you already saw. I could also do greater than or equal to, which is a greater than and then an equals. As you might expect, I could do less than or equal to, which is a less than and then an equal sign. Okay. And then this is a markdown cell, remember, and if I hit Shift Enter, it's going to format my little list I made as a little bulleted list. So that's kind of nifty. Okay.
Just one request. Can you scroll up a bit so we can see your for loop? Just the cell 27. Couldn't see all of it.
There we go.
Just in case you were still working on doing that.
Yep. All right. So I have 2 things I want to say, and then I'm going to let you
Dr.
go
McDonald, I'm sorry, I have another question for you. Can you write a comment in this cell about what we're doing in this cell?
Oh, yeah. I could do my little hashtag, and then I could say, I'm going to add all the negative values to a new list. And maybe I shouldn't even say add. Maybe I should say append all the negative values to a new list. Okay, so there's one other thing that I want to show you that happens to my students all the time. So you're working along, you're doing your notebook, da-da-da-da-da-da-da, and then somebody comes and bothers you and you like get distracted and you close out of your notebook. And then you come back later and you're like, oh, I want to pick up working on my notebook again. And you reopen it. And you go down here to the bottom and you start working on your code again. And it gives you an error message. And it says something like, energy kcal is not defined. And you're like, what do you mean it's not defined, computer? It's defined right there. How can you tell me it's not defined? When you exit out of your notebook and you come back, sometimes it doesn't remember all the cells that you've already run. So one thing that I always like to do when I have to exit out and come back is the first thing I do is go to kernel, restart and run all, and then that reruns all of my cells. Well, at least it does it until it reaches an error message. And then I can do shift enter and run the rest of my cells. So just remember, if you ever exit out of your Jupyter notebook, when you start back, if you want to pick up where you left off, you have to rerun all of your cells. And if you want to do that easily, you can just go to kernel, restart, and run all. Okay? And I did two things. I came up here and I changed the name of my notebook. So this used to say untitled, and I clicked on it and I gave it a new name. And then I made a markdown cell. Remember, I used this little drop-down menu to make a markdown cell, and I typed just kind of a heading for my notebook. Strictly speaking, these markdown cells don't do anything. You don't have to do this, but I always like to start with a markdown cell so that when I look at this notebook later, I'll remember what it was about. That's kind of the reason that I do it. Okay. All right. So let me tell you a little bit about what we're going to do in this lesson. So I think that there are a lot of resources on the internet where you could learn the things that we learned in our first hour, the things that we learned in that introduction lesson. But then I think lots of times they're just like, okay, great. Now you know Python, go do what you want to do. And I think a lot of the online learning Python resources don't really emphasize how you would actually apply this to the kind of work that you need to do. Okay, so I'm going to show you what we're going to be doing today. And if you don't want to click along with me, if you just want to stay in this notebook, that's totally fine. I'm just going to click over and show you what we're going to be doing. Okay, so I'm going to click back over to my main tab, and I'm going to do the thing that I've been telling you not to do, and I'm going to go into the data folder. And in this data folder, we have all these different files for you. And I'm going to go into this folder called out files. Now, what these particular files are is that these are output files from quantum chemistry calculations of molecules. Okay, so I'm going to click on this one. I'm going to click on the ethanol one. And this is what this file looks like. And this is an output file from the Sci4 quantum chemistry software package. And Sci4 is a software package that lets you calculate things like the geometry and the energy of molecules. And the main point that I want to make to you about this is that this file has 10 bazillion pieces of information. There's so much information in this file, and we're really only interested in this piece of information, the final energy, okay? This is really what we want to know. So what we want to do, what we're going to focus on for our class today is we're going to talk about how you can search through this file to find one particular piece of information that you care about and how you can pull out that piece of information. And I recognize that a lot of you may not have done a quantum chemistry calculation. This may not be the kind of information that you collect in your work. But I think that we can all imagine a situation where you have a big complex file with lots of information in it, and you need to find and pull out one particular piece of information. So that's really what we're going to be focusing on today. Okay, so I'm going to click back over here. I'm going to go back to my MolSSI workshop folder. And I've already got my new file parsing notebook open, so I'm just going to click over to it. And now I am ready to begin. Okay? Okay. So it stands to reason that if what we're going to do is search through that file for information, the first thing we need to do is we need to tell the computer where that file is. And if we're going to tell the computer where the file is, we need to know where we are now on our computer file system. So this is actually not a Python command. This is a Jupyter Notebook command. But if you type pwd, that stands for print working directory. And if I hit Shift Enter, it is going to tell me where I am on my file system. And I'm in Home, nanoHUB, and then this is my name on nanoHUB, so this is probably different for you. And then I'm in my MolSSI workshop folder. So everybody's should look something like this, okay? Now, we're all using the nanoHUB resources, so everybody's looks something like this. But if we had a Windows user among us and they were running things on their own Windows computers, their like little slashes would be going the other way. Okay? So I'm going to show you something, and then I'm going to tell you why you should absolutely never do this. Okay? So you could do this. You could say ethanol file, and then you could just type in the file path. And I tell students that the file path is like, think about what folders I clicked on to get to the file. I clicked on the data folder, and then I clicked on the file that said, the folder that said out files, and then I clicked on the file ethanol.out. So that's what the file path is. It's like the sequence of folders that you would have to click on. Now, you should never do this. I'm going to write a comment to myself. You should never do a file path this way. And you're like, what's wrong with that, McDonald? Why should I never do a file path this way? Because if you're writing your code on, say, a Mac computer where the slashes go this way, and then you give your code to somebody else in your lab, and they are a Windows computer user, then your code is not going to work on their computer at all, which seems terrible. In the computer science world, we call this interoperability. We want codes to work on all different kinds of computers. And it's pretty bad if your code can only work on the kind of computer that you wrote it on. And if you hard code a file path this way, you make your code not interoperable. So this is terrible, and you should never do this. And you're like, well, great, McDonald, what should I do instead? Instead, we're going to learn how to use a library that handles things related to the operating system. And this is the first time we've had to use a Python library, so I'm going to talk about it a little bit. So a library, when I use the word Python library, that's just a collection of code that usually someone else has written, that you're going to use within your code. And if you want to use a Python library, the first thing you have to do is import it. And that's not hard to do. You just type the word import, and then you type the name of the library that you want to use. We're going to be using a library called OS, which contains code related to the operating system. When you hit Shift Enter, nothing is going to happen, okay? It'll appear that nothing has happened, but in fact, it has imported all of the functions from the OS library, and we're now going to be able to use them. Okay, so now I'm going to do this the right way. Now I'm going to tell the computer where my file is. by creating a variable called ethanol file. And now, instead of just typing it in, instead of doing the bad thing that a terrible person would do, I'm going to use a function from the OS library. Now, when you use a function from a library, you begin by typing the name of the library, so that's OS, and then you type a dot, and then you type the function that you want to use. And the function I want to use is path.join. Okay, so I'm going to type os path join, os.path.join, and then in parentheses, I'm going to put the things that I want to assemble in my file path. So that would be data, out files, and ethanol.out. And then just to show you what this does, I'm going to print ethanol file. And you notice that it looks exactly like what I told you not to do, okay? It looks exactly like what I said not to do. But the difference is, if we now ran this code on a Windows computer, it would set up the file path appropriate for that computer. Okay, so even though it looks the same, it's really not, I promise you. Okay? Okay, so now we've told the computer where the file is. So then the next thing we need to do is we need to open the file and read in all of the information from the file into our code. Okay? So the first thing I'm going to do is I'm going to create this little helper variable called out file. And we're going to talk more about this in a second. Okay. I'm going to create this little helper variable called out file, and it's going to help me open the file. So I'm going to say open the file, and then I have to tell it what file I want it to open. And I'm going to give it the file path that OSPathJoin just put together for me. And then I'm going to put in quotes an R. And that means I am opening this file for reading, because what I want to do is read it in. Okay? Now I'm going to create a variable called data. And data is going to be equal to out file. Remember, that's my little helper variable that's holding my file open. And then I'm going to say out file dot read lines, open parentheses, close parentheses. What this is going to do, okay, and this is very important as to how read lines works. What this is going to do is this is going to take every line of the file and read it in to a new list called data. Okay, so data is going to be a list where every element of data is a line from this file. So read lines sucks in all of the file and it saves it line by line in this list called data. Okay? And then once you've done that, you want to close your file. So you're going to go out file dot close. And remember, programming is just like kindergarten. If you get something out, you need to put it away. If you spill it, you need to clean it up. If you open it, you need to close it. So don't forget, anytime you do an open, you always want to do a close. Okay? Now, when I hit Shift Enter, it's going to seem like nothing has happened. But now, if I were to print like data, 10, this is going to print a random line from my file. And it turns out that line is not very interesting. I could try printing line 0, which turns out to be blank, or I could print line 100, which also turned out to be blank. Let's go back to 10. I could print a random line of the file, and I now have all of the lines of the file accessible to me in this list called data. Okay? And if this is not working for you, there's a couple possibilities. Number one is that OS path join does not check to make sure that this file exists. All it does is construct this file path for you, okay? If you try to open it and this file doesn't exist, it will give you an error message. And if that's what happened to you, then you probably did the thing that I said not to do, and you started your notebook from within the data folder. So you want to double check and make sure that your file parsing notebook is in the MolSSI workshop folder and that you can see the data folder underneath you. Okay? Okay. Again, I'm going to pause just another second here. I'm going to review what I did. These are just comments from kind of when I was lecturing, so you do not need these in your code. But what we've done so far is we've imported this new Python library called OS. We've used a function from OS called OSPathJoin to construct our file path. The reason we needed a file path is because the first step of parsing through a file is telling the computer where it is. And that's what we've done right here. The next step is opening that file, reading in all of the information with read lines, and then closing that file. I remind you that the way that read lines works is it takes every single line from the file and it stores it in this list called data. So after we ran this cell, it appeared that nothing had happened. But if we printed some particular line of data, then we can now see that we have all the information from the file saved in this list called data. Okay, so I know we're still waiting for people to get caught up, but I want to give you another quiz. Okay, so I'm going to actually make a markdown cell and I'm going to type out the quiz instructions. You don't have to do this if you don't want to, but it's a good practice for using markdown. Okay, quiz. Using commands that you already learned, figure out how many lines were in the file. Hint, think about how read lines works and what is in the list data. Okay, so that's your quiz. All right, let's talk about how you could address this little quiz that we did here. So again, the hint was to think about how read lines works. So remember, read lines pulls in all the information from the file and it saves each line from the file as an element in the list data. So if we could just figure out how many elements were in the list data, that would tell us the lines in the file. So I hope we remember that the way we would do that is we would use that len function. So if we just printed len of data, there we go. If we just printed len of data, that would give us the answer. There were 270 lines in the file. And remember, the reason that this worked is because the way read lines always works is it pulls in all the information from the file and saves each line as an element of the list data. So if we print the length of the list data, that is the number of lines in the file. All right. So now let's get down to business and let's do this for real. Let's start looking through our file for our critical piece of information. I still have the file open on my computer, so you don't have to click on this. I'm just going to click on it. So I remind you, in this whole big file, The critical thing that we're looking for is this line that contains final energy. So what we need to do is we need to go through every single line in the file and look for that final energy. And if we see it, we want to do one thing. And if we don't, we want to do something else. So what does that sound like? What does that sound like that we've already learned? We're going to go through every line in the file. Is there a data structure that we learned in our first lesson that could be useful here? It's the for loop, okay? So we remember that every line in the file is now in this list called data. So I'm going to set up a for loop to look through all the elements of data. So I'm going to say for line in data, don't forget your colon. And remember, I could have used any word here for my variable name. I just chose line because that made sense to me. This data is the lines from the file, so that's why I called it line. So for line in data, if I find the words final energy in the line, then that line is really important to me and I want to pull it out. So I'm going to say if final energy is in line, then I want to take that line and I want to set it equal to a new variable called energy line. So I'm going to save that line, the line where I found final energy, I'm going to save it as this new variable called energy line. And then I'm going to print it so I can make sure that I've found it. Okay, ready? I feel like this is a big moment for our code here. Are we going to find it? Oh, look, there it is. There is our line with the final energy. Okay, so yes, there's a question in the chat. I was able to create a new variable called energy line within my for loop. Okay, now, presumably, the piece of information that I really care about in this line is probably this number. Okay, probably my advisor wanted me to calculate the energy of all these different molecules and then report what that energy was. So probably this number is the really important key fact to me here. So what I want to do next is I want to, right now, energy line is like one thing. Like this whole line is one thing. So I want to take this line and I want to split it up into its different words, okay? So the way that I'm going to do that is I'm going to use a function called split. So I'm going to create a new variable called words, and then I'm going to say energy line dot split, open close parentheses. And then if I print words, let me show you what this does. So what this does is it takes what used to be my like whole line and it splits it into the individual words. And I want to emphasize, I don't have to call this words. I could have called it something else. But just in my mind, I was sort of splitting the sentence up into its different words. So that made sense to me. But I don't have to call it that. I could call it something else. I do want to note that I put nothing in my parentheses here. But if I put something else in the parentheses, I could split it on a particular character. Like if I wanted to split this at the colon, I could say split on the colon, and then it would just split it into two parts. If you don't put anything, it splits it based on spaces, which lots of times is what you want to do. But you can split it on a particular thing, on a particular character, if that's what you want to do. Okay? So again, I've created a new list called words. That words list is going to be the output of my split function. And since I didn't put anything in here, it's just going to split it based on the spaces. Okay? Now, I said that what I was interested in was the number, was this piece right here. So I'm going to count over, and this is index 0, this is index 1, this is index 2. So the number, the thing I really care about is index 3. So I'm going to create a new variable called energy, and it's going to be words number 3. So I'm going to take this list that's called words, and I'm going to pull out just index 3, which should just be that number. And then I'm going to print it to make sure that that worked. Okay, now let's say that I wanted to take this energy that I just pulled out and I wanted to add 50 to it. And I'm like, you're like, well, McDonald, why would you want to do that? That seems crazy. Well, just pretend that I did. So I'm going to take the energy and I'm going to add 50 to it. And it's like, error message. What's the problem here? Why can't I add 50? And this is an example of those data types that we were talking about earlier. So if I check the data type of energy, it is a string. So even though it looked like a number to me, okay, even though it looked like a number to me, it is really a word. And that's why I can't do any math operations on it. So I probably want to change that. I probably want to change it to where this is a number. So I remember that the data type for a decimal number was a float. So I'm going to say energy is equal to float energy. And it's going to look like nothing has happened. But if I now check the type of energy, now it is a float. And if I try to do math on it, now that works. Okay? So again, the reason I couldn't do math on this is because even though it looked like a number, it was really a word. And you're like, well, why was it a word if it looked like a number? It all goes back to that read lines business, okay? When read lines reads in the data, it always reads it in as strings. It always reads it in as words because it doesn't know what it is. So down here, even though it looks like a number, if I check the type, it turns out it's a word. And that's why I couldn't do any math on it. In order to force it to be a number, I said energy equals float energy. The word for this, like the computer science word, is recasting. This is when you change the data type of a variable. I'm just going to put a note in. All right. That's when you change the data type of a variable. That's called recasting. And then once I do that, it is a decimal number and I can do math on it. All right. So you might be wondering, okay, McDonald, I see what you've done here. I see how you went through this file and you pulled out the critical piece of information. Like, I get that. But would I really do this? I mean, why can't I just cut and paste? Why can't I just look through the file and find the number and cut and paste it into a spreadsheet? And if you only had one file, I could see how you might cut and paste. But the great thing is, if you write the code and you can do it in the computer, then you could just as easily do this for one file or 10 files or 100 files or 1,000 files. Okay? So the final thing that I want to do today is I want to show you how to extend this to, instead of just searching through one file, how can we search? And I'm going to click back on this. Remember, I actually had this whole folder of output files. How can I search through all of these output files and get all of the energy? That's the last thing that I want to do today. Okay, so the first thing that we need to do is we need to make a list of all of these files. We need to make a list of all of the files that I want to search through. And in order to do that, we're going to use another new Python library. And this Python library has the great name of glob. So I'm going to say import glob. So this is a new library. And I don't really know how I would categorize glob, Dr. Nash. It kind of has to do with multiple files or folders. Like, that's kind of what glob does. Okay? All right. So now that I've got glob imported, I am going to use glob to get a list of all my file names. Okay. Now, I remember before that whenever I want to use a function from a library, I type the name of the library. So that's glob. And then I type the name of the function. And in this particular case, the function that I want to use is also called glob. Okay. So eventually I'm going to need to say glob.glob. Okay, but I'm getting a little ahead of myself because now the thing that I need to feed into this is the folder where I want it to look for all those file names. Okay, so I'm going to come back to this, but I'm going to go up a line and I am going to create a variable called file location. And I'm going to use OS path join that I already used before to specify where the folder is that I want to look in. So where was that folder? I clicked on data, and then I clicked on out files. Okay, now I'm going to click back over here. You don't have to click with me. Okay. Look at this list of files. They all end in dot out. So what I'm going to do is I'm going to say star dot out. And star is called the wildcard character. And it matches anything. So this is going to say look in data, out files, anything dot out. Okay? And if I feed that file location into glob.glob, now if I print my file names, oh wait, I messed something up. Oh, somehow an extra dot snuck in right here.
Dr. McDonald, before you execute this, maybe you can talk about the error message and how you found what's wrong from reading it.
Oh, yeah. So Dr. Nash taught me that whenever I get an error message, I should always look at the very last line. And it says I have an invalid syntax. And then if I come up here and I look for the little caret, it's pointing to where my mistake is. So my mistake is like right here. And the mistake that I made is I'm supposed to have commas and I accidentally put a period. So I need to fix that. I need to put my comma there. Okay, now this is going to work. Okay, so look, I now have this list called file names that goes through and lists all the different files in that folder. Okay, so now, watch me now. This seems complicated, but you know all of these tools. You have all the tools to do this. Let's think about what we need to do here. We need to go through this list of files, open each one up, and then go through all the lines in that file. So we need to go through this list of files, open one of them up, and then go through all the lines in that file. So what does that sound like? What data structure that we've already learned about in this class do I use to go through a list? What data structure does that sound like? Exactly. It sounds like the for loop. And in fact, what I'm actually going to need to do is I'm going to actually have to use two for loops, because I'm going to have one to go through the list of the file names, and then I'm going to have another to go through the lines in the file. Okay, so let's see what this would look like. I'm going to say for file in file names, colon. Okay, then I'm going to open up one of them. So and I used all these commands in my last lesson. This should all be familiar. So I'm going to say out file equals open file for reading. Then I'm going to read in all the information with read lines. So I'm going to say data equals out file dot read lines, open close parentheses. Then I'm going to close it. Outfile.close. Okay? So all of these commands you've seen me use before. Okay? All of these commands you've definitely seen me use before. But now, instead of just doing them for one file, now I'm going to do them for every file in this list of file names. Okay. Now, once I've got the file open, this is going to look exactly like what I did up there. Now I'm going to go through all the lines in this particular file. So I'm going to say for line in data, if I find final energy in the line, what am I going to do? I'm going to save that. I'm going to have energy line equals line. Okay. So this is exactly what I did before. Okay. Then I remember, because I've already done it, that then I wanted to split energy line into its words. So I'm going to say words equals energy line dot split. I did that before. Then I remembered that the energy was equal to index 3 in words. And then if I really want to be snazzy, I remember that I had to recast this as a float. So I'm going to squeeze that in and do it all in one line. I'm going to say energy equals float words 3. And then I'm going to print the energy. So now, big moment, if I run this cell, I should see 10 different numbers for those 10 different molecules. Amazing! I did it. All right, so I know that was a lot, so I'm going to review what we did. First, we imported a new module called glob. Then we specified the file location using OS path join. We looked in the data folder, then we looked in the out files folder, and then we introduced the wildcard character to find every file that ended in .out. We then fed that file location into glob.glob. And remember, it was the function glob in the library glob. So it just kind of ended up being glob.glob. We fed that into glob.glob, and that gave us our list of file names. And then we looked at those. And then, this is no new skills. This is exactly what we did last time. We used a double for loop. The outer for loop goes through that list of file names and opens each one up. And then the inner for loop is exactly the same for loop that we wrote before, where we looked for the line that contained final energy, we saved that line as energy line, and then we did the split and pulled out just the numbers, and we printed all those. Okay? So if you've got this and yours is printing all of the numbers, then we're good to go. Okay, I'm going to show you two more things, or maybe just one more thing, because then Dr. Nash is going to tell you about your homework. So up here, what's not very useful about this list of numbers? Like, what would be better? Well, I don't know which file this number came from. So I'm going to come back up here and I'm going to change my print statement. Okay. So instead of just printing the energy, I'm going to do the F print. Okay. And then in my F print statement, I'm going to print the file that I'm on. And then I'm going to print a colon. And then I'm going to print the energy from that file. So now if I run this again, now it's telling me which file each of my numbers came from. All right. And if you are having trouble getting this to print, but it was working before, double check your F print statement. Make sure you've got the big F and then the opening and the closing parenthesis, the opening and the closing quotes. Okay.